Alrighty then, corn children, children of the corn, it is a fine day for mathematics. Let's take a look at a review of exponents. Yeah! Woo! All right, here are the rules. Let's go through them. Rule number one. Rule number one, if you are multiplying, see the little dot? Yeah. If you are multiplying and the bases are the same, there's a strange thing that happens with exponents. The exponents do not multiply. No, they're like bad kids. You say multiply and they're like, no, thank you. We won't do that. Instead, when you say multiply, I suppose that should be capitalized. When you say multiply, they say add. What? When I say multiply, you say add. Multiply, add, multiply, add. Yeah, that's right. Pom-poms. Let's take a look. If I have x to the third times x to the second, this does indeed equal x to the fifth. If you're not sure, you can break it down. Break it down now. Hey, look, there's 5. Yeah, I know, right? Rules for exponents, they're fancy. Number 2. Well, kind of makes sense. If we're dividing, then they subtract. And they subtract top minus bottom. Now, what can happen? This could end up being a negative number, and with a negative exponent, it will send it back to the bottom. There's a way around that, though. Let's take a look at 2 examples. Well, first let's do a simple example. This is just going to be x to the 5th, which assumes it's x to the 5th in a numerator, but you don't have to write the over 1. If you're really concerned about this being true, you can. It makes my heart hurt to have to do this. 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Over x squared. And then because these are all multiplying, they're all factors, we can cancel. X over x is a form of 1. You're multiplying by a form of 1. When you multiply by a form of 1, it doesn't do anything, so you can cancel those out. Yeah, and that's 5 left. That's why it's x to the 5th. Now, as another example, if we were to flip this, and I'm going to make these smaller so it isn't so difficult. We'll go with 5. If we flip this, please notice, using the rule, you have to subtract and you get x to the negative third, and then the negative reciprocates to the denominator. Now, you have an understood 1 in the numerator, so it's not blank. I honestly don't really think this through that way. I think about it more. I'm kind of like visualizing this. I don't usually write it out. And then when you cancel your forms of 1, that's a form of 1, that's a form of 1, there are 3 left, but where are they? Well, if there's more in the bottom, the remaining ones would be in the bottom, but not with the negative exponent. The negative exponent is your subtraction rule, and it's a negative exponent in the top, which sends it to the bottom. All right, think that through. Personally, I think visualizing this and where they end up, they're positive exponents in the denominator when there are positive exponents in the denominator larger than the top. All right, whatever. Number 3. Number 3 is a biggie. This is a power raised to another power. Yeah, I don't know, right? Here's where you multiply exponents. Straight up multiply. Take a look at an example with me. The answer is, multiply those together, just multiply 6. Why? Well, think about this. I'm going to use my magic thumb. If I put my magic thumb over this and you see a square, doesn't a square mean whatever is under my thumb, you multiply together 2 times, squared twice? Like if that was a 9 under my thumb, it'd be 9 times 9, because that's what a square means. If it was a q under my thumb, q squared means a q times a q. Well, what's under my thumb? Oh, it's It's an x cubed. So this means x cubed times another x cubed. That's what squaring does. Well, now you can either remember the rule from before. When I say multiply, you say add. Multiply, add, multiply, add. Or you could break it down again. And there's 6 of them. Oh, x to the 6th. I don't do any of these steps. I know my rules because I'm a math teacher. So I know you just multiply. This is your justification on why that works. Now this can get a little bit trickier, first of all, as we've already seen, if there are negative exponents, and second of all, when we use them in combination with one another, and third, if there are also coefficients involved. What? Yeah, here's what I'm going to do. And feel free to pause the video, to slow it down, to replay the video, to make some sense of it. I'm going to put all 3 of these together at once. All right, here we go. Giant problem. 3 x squared y to the 3rd 6 x to the 7th y nothing. Out here, I'm going to put a 4. That's how I roll. I know. All right, let's take a look at this. There's more than one way to do this correctly. I'm going to work this in a way that I think will make sense to most of you. With the, please excuse my dear and Sally PEMDAS, parentheses comes first. So here's what I'm going to do. Whoops. I am going to ignore the exponent on the outside of the parentheses. I am going to look inside the parentheses, focusing on the parentheses, and simplify within the parentheses first. So I'm really starting here with the P, looking inside the parentheses. Now, once you're looking inside the parentheses, there are no more parentheses, so I'm going to go ahead and look at my exponents, because that would be the E. So I'm working the parentheses first, and then exponents within the parentheses. If I look at the exponents within the parentheses, these are both x's, so I can simplify. These are both y's, so I can simplify. All right, I'm going to hold off on the 3 and the 6. I'll do that in a minute. So I'm not going to write them down. And don't forget, there is a 4th power out there. I'm focusing right here. Well, the rule is that you subtract exponents when dividing. So if I subtract exponents, 2 minus 7 is negative 5. I'm not going to write x to the negative 5th in the numerator. I'm going to use the negative and drop it like it's hot and put it in the bottom. I'm also visualizing if 2 of these x's cancel, there would be 5 left, and where would they be? They'd be in the bottom. All right, do it whatever way you want, but you better get x to the 5th in the denominator. Looking at the y's, y cubed, y to the, oh, it doesn't have it. Put the 1 there. All right, the rule is 3 minus 1 is 2. It's positive, so it's going to stay up here in the top. Yeah? All right. Within the parentheses, we're back up here to PEMDAS. Within the parentheses, I've tackled the exponents. I will now do the multiplying and dividing. This 3 and this 6, these are not exponents. They're not teeny-weeny little numbers. These are your regular division. 3 divided by 6 is 1/2. You can put the 1 there. It's silly, but you can. And there's your 2. Aight. So, is there anything left inside the parentheses that still needs to be done? Is there any adding and subtracting? No. So I have checked off the parentheses. So now you start this all over again. We have already done parentheses. That's already tackled. So now we work at the exponents. What does that mean? Now you're going to tackle that 4. Oh, okay. What are we doing here? We're raising to a power. Now here's how this works. It's a 1, so you don't have to do this, but it's a 1 to the 1st. It's a 2 to the 1st. Even the coefficients need these exponents. Everything, not just the y's and the x's, everything is going to be raised to the 4th. Okay, so the rule is a power raised to a power is when we multiply exponents. So this becomes, I know it's a 1, you don't have to do it because it's a 1. This is 1 to the 4th, which is 1. This is going to be y to the multiply 8th. The 2 is in the parentheses. The 2 is raised to the 4th. You multiply the exponents. This is 2 to the 4th, multiplying here, x to the 20th. Now the only thing left to do is to simplify the ridiculously obvious 1 to the 4th is 1. I'm not even going to write it because 1 times y to the 8th is y to the 8th. 2 to the 4th is not 8. Did you hear the angry voice? 2 to the 4th means 2 times 2 times 2 times 2. That's 16. If you don't believe me, get your calculator out. And there's your solution, people. So I've used many of these rules in concert with one another, singing a happy, happy little song. I hope that helps.